Day one, pre-lesson, part two. I know this is a doozy. It's got a lot of information. So, um, so far, the first translation transformation was shift up or shift down. It has to do with letter D. Then we thought about compression or vertical stretch. It has to do with letter A. Now we're going to move on from that. We're going to start talking about reflecting over the x-axis. Remember, this is our x-axis. So let me give you an example. Y equals x. We know that that looks just like this. And the numbers that I kept giving you was -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. And if we plot all these points, we would get this line. Now, what if I made the same chart, and I went -3, -2, -1, 0, 1, 2, 3. Well, this says take the opposite of whatever x is. So that would be, instead of -3, -3, it'd be -3, +3, -2, +2, -1, +1, 0, 0, 1, -1, -2, -3. Now, if I plot all those points, we'd share that in common. 1, -1 would be right here. 2, -2 would be right here. 3, -3 would be right about here. And then we would do the same thing on this side. Now, what really happened? Well, think about this x-axis as like a stick, and we just flip this black graph, flip it right over the x-axis. Reflect over the x-axis. That's what that negative does. We can see it with our very eyes. So we take the x, and it's like a little spinny thing. We spin it 180 degrees. This would land on this. This would land on that. Now there's more to it. And this gets a little tricky. So hang in there. So what I'm saying is, okay, let's make the rule. So if A is negative, it's going to reflect over the x. Now I just went off this big rant about all you got to do is spin it, all you got to do is spin it. There's a little more coming, so pay attention. Notice the y-intercept is right here. That's why we could just spin it, and it works. There's a little twist coming. Let's take this guy, graph him, based on how we know to graph. -4, 1, 2, 3, 4. There's our y-intercept. Slope is 3 over 1. 1, 2, 3, right 1. And it would look something like that. Now, the key to this is, look at this, -4, -4, -3, +3. Now, and I know I said, hey, compare this always to your parent function. But in this case, they might say, hey, reflect over the x-axis. In other words, they're going to give you this and say, what would the equation be, that would reflect this over the x-axis? Well, knowing that a negative A reflects it over the x-axis, you would just take that and make it negative. But what if they actually had you reflect it over the x-axis? In this case, you would be wise to actually think of this now as your y-axis and this as your new x-axis. If you want to stick with that flip it over the x rule. So this purple part would go this way. This purple part would go this way. So I'm just getting you ready for problems that are coming where you can't just flip the x-axis and expect it to work. If I did that, that would end up here, this part would end up here, this part would end up here, and that is not correct. And if you check it out on Desmos, type this in, you'll notice you're going to get the purple one for this, and then the black one for that. So you notice how it was moved down? So that's kind of like your new origin. And and then you can flip it over the x-axis, and that will work. You're going to see more of these examples in just a second. On to parabolas. So this stuff works for all graphs. So not just linear line. Now we're into quadratics, which is a fancy word for parabolas. So I'll explain more of that later. But we're talking about y equals x squared. Notice this is squared. The linear equations have stuff like this, where this is a 1 and that's a 1. Now we're introducing you to parabolas. So we take a look at all these x's, pop them in here, square them, we get 9, 4, 1, 0, 1, 4, 9. And if we actually took the time to graph it, it'd be 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and you kind of get the idea of where this stuff is coming from. So there's where a parabola comes from, this equation. Now, little test. See if you've been listening. What does this plus 2 do on the end? Well, that's going to go up 2. So I know what g of x looks like just because of that. G of x is going to take, we're going to move everything up 2. So this goes up 2, and then we just recreate it to the best of our ability. So there is g of x. All right, that's review. Now all of a sudden, for the first time, we're going to talk about this letter c. Notice I have a plus c, but this is plus something. This is minus something. So we're going to find out what happens. I'm going to show you something. So what I've done for this parabola is I've put in negative 3 to 3, and then I plugged them all in. So for example, negative 3 plus 2 is negative 1, squared is 1. And then I did that for negative 2, negative 1, I got all these points. I'm not graphing them all. I'm going to start with this one, negative 3, 1, 1, 2, 3, 1. Negative 2, 0, right there. I'm going to make that bigger. Negative 1, 1, so negative 1, 1, and I can already see what's happening. So, listen carefully. Remember the purple one, y equals x squared? It's right here. The only change I made to this over here is I went plus 2. Notice something strange. Plus 2, if I was to guess, I'd say, oh, that moves right 2. And it does just the opposite. It moved it left 2. So, with this green marker, without making any of this, what do you suppose x minus 2 does? That's going to move it right 2. So I go, it's the purple one, bing, bing, to the right 2. And you're starting to get it, okay? So plus c equals left, minus c equals right for any kind of graph. There's a little bit more I got to show you. Grand finale. See if you guys can remember something about absolute values, because they're going to give you graphs that have absolute values in them, functions. So this is just saying, take x, put it in there, and take the absolute value of negative 3. Well, that's 3. Absolute value of negative 2 is 2. 1, 0, 1, 2, 3. Plot these points. Well, it's going to look like this. Negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, the same thing here, okay? Now, not so concerned about that, but you need to have a great understanding of this. Kind of memorize it. So now the question is, what does this do to that? This is the parent function. Well, it's going to double it. Remember what we said? If a is a whole number or greater than 1, it's going to be a vertical stretch. It means it's going to go up faster. So I'm going to grab my red marker and make this red, so you know what I'm talking about. It's going to go up twice as fast. How do I say it? Vertical stretch, factor of 2. Now the book gets a little funny. They write the same thing different. This says g of x equals 2 times f of x. How confusing is that? Well, f of x is the same thing as the square absolute value of x. So that's just a more difficult way of telling you the same thing. So be on your guard for that and just don't panic. What about this? Well, we just talked about that. I better grab a different colored marker before I confuse you. I'm taking the red one off so we don't get all confused, because we always compare this to the parent function. So there it is. What does this plus 2 do? Well, technically, there's an A here, there's a B here. This is my plus C. Plus C means left. So I got to take my parent function and slide it to the left 2 units. And then they can ask us all these questions about the domain and where's it increasing and where's it decreasing. Now let me throw a bonus in there, almost done. What if this was actually 1/2? Well, that would be a vertical compression. So instead of it going up like this, it would go up slower. It's just flatter. It's compressing this original parent function. So I throw that in for free. Let me make sure we're done. All right, bonus education time. So I'm going to add something here. What if they add a couple things here? Well, first of all, we got to know that our parent function is y equals x squared. So I'm going to do that with purple. What does this do? Well, here it comes. That's going to move it to the right 2, bing, bing. And I'm going to make it dotted because it's not done. Then I got to move that whole thing down to 1, 2. And now I'm going to actually draw it in solid. I'm going to erase my previous step. And there it is. Perfect? No. All right. Now, what if you had a problem like this where it said, number 1, graph this. Like, okay, we did it. Then number 2, they asked you to think about what would happen if that happened. Well, what do you mean? Well, the only thing I changed was this. When that's negative, there's a reflection over the x-axis. Here's the thing. You see, the original vertex moved right down. It's kind of like it brings the y-axis and the x-axis along with it. And now here's my x-axis. The rule is flip it over the x. So I say, oh, okay. So I flip it over the x. I don't know what color to make it. I guess I'll stick with purple because I've already used red. And that would be just like this. Play around with it on Desmos just to confirm what I'm trying to say to you. So that was for free. All right. Check out those example problems.